All right, let's pull back the curtain on something we all use every single day, but probably never think about. We're talking about that little bit of magic that gets your devices online the second you connect to a network.
I mean, think about it. You join a Wi-Fi network, maybe type in a password, and boom, you're online. You didn't have to mess with any settings. You didn't have to type in a bunch of weird numbers. It just works. So how does that happen?
Well, to really appreciate how amazing today's system is, we got to look at how things used to be done. Seriously, picture an IT admin having to physically walk to every single computer and manually type in its IP address. It was slow, a single typo could break things for everyone, and it was just a massive headache. Now, it's completely automatic. That jump from manual pain to automatic perfection is what we're digging into.
And the hero of our story, the thing that makes all this magic happen, is a protocol called the Dynamic Host Configuration Protocol, version 4, or as we'll be calling it, DHCP4. It's the silent workhorse that makes all our connections just happen.
Okay, so here's our game plan. We'll start with the problem that needed solving in the first place. Then, we'll walk through the 4-step conversation that gets your device online. After that, we'll talk about why you're only leasing your address. And finally, we'll see how this is all put to work in the real world.
So how exactly does DHCP fix that whole IP address mess? Well, it all boils down to a super fast, really polite 4-step chat between your device, which we'll call the client, and a DHCP server on the network.
It all starts right here. The moment your phone joins a new Wi-Fi network, it's brand new and has no address. So its first move is to basically shout into the digital void. It sends a broadcast message out to everybody on the local network, pretty much yelling, "Help, I'm new here. Is there a DHCP server around? I really need an IP address."
So any DHCP server on that network hears this cry for help. It checks its list of available IP addresses, grabs one, and sends a message directly back to your device. This is the offer. It's the server saying, "Hey, I heard you. I'm a DHCP server and I've got an IP address for you right here." How does this one sound?
Your device now has an offer on the table, so it sends out another broadcast to the whole network. This time, it's a formal request. It's announcing to everyone, "Hey, thanks for the offer. I'd like to officially take that IP address you suggested." And doing this as a broadcast is key because it lets any other servers who might have made an offer know that the position has been filled.
And for the final step, the server that made the original offer sends one last message straight to your device. This is the acknowledgement, or ACK for short. It's the final handshake. It says, "Awesome, it's all yours. That IP address is officially assigned to you. Welcome aboard." And just like that, in a fraction of a second, your device is online.
Okay, so your device has an IP address. Fantastic. But for how long? This brings us to a really important idea. That address isn't yours to keep forever. You don't own it. You're actually just renting it for a little while. This temporary rental agreement is called a DHCP lease. You can think of it just like leasing an apartment. You get to use it for a set amount of time, but when the lease is up, the landlord, the DHCP server, can give that space to a new tenant. It's a super efficient system because it makes sure IP addresses aren't wasted on devices that have left the coffee shop or have been turned off.
So how long do these leases last? Well, it depends on what the network admin decides. But for a typical home or office network, you're usually looking at something between 24 hours and a full week. It's a good balance of stability and efficiency.
The good news is, renewing your lease is way easier than the first time around. Before it expires, your device just shoots a quick request directly to the server that gave it the address in the first place, basically saying, "Hey, my lease is almost up. Can I keep this address?" The server just replies with an acknowledgement, and you're good to go. Simple as that.
All right, we've got the theory down. But what does this actually look like when someone sets it up? Let's take a peek behind the scenes and see how a network admin gets a DHCP server up and running.
First off, you don't always need some giant, dedicated server computer for this. For most homes and small offices, your router, that box with the blinking lights, is powerful enough to do the job. Your home Wi-Fi router is absolutely doing this for you right now.
And check this out. This is how it's actually configured. An admin just types in a few simple commands. They create what's called a pool of IP addresses to hand out. They set the default gateway, which is just the door to the rest of the internet, and they point to a DNS server, which is like the internet's phone book. It's really just giving the router a clear set of instructions for managing traffic.
And here is the proof in the pudding. After setting it up, the admin can run a command to check the server's work. And right here, we can see it. This output shows the bindings, the link between a device and the IP address it's been leased. You can see plain as day that the router successfully gave out the address 192.168.10.10 to a new device. That's automation working perfectly.
So, let's wrap this all up. What's the bottom line? DHCP v4 is that invisible hero that automates what used to be a really painful manual job. It all works because of that simple four-step conversation: discover, offer, request, acknowledge. And by leasing addresses instead of giving them away forever, it keeps our networks running smoothly and efficiently. And the best part? This powerful system is probably humming along on your own router right now.
It really makes you stop and think, doesn't it? We just unpacked this incredible hidden system that makes our digital lives possible, which leads to one last big question. If a protocol that's been around for decades can automate something so complex so perfectly, what other amazing automated systems are out there running our world from just behind the curtain?